Hey everyone, welcome back. In this video, we are going to review the derivative formulas for the 6 inverse trig functions. So these may look overwhelming. They do involve the chain rule. However, what you will notice is that you have a nice little pattern that is going to make it a little bit easier. So what you'll notice is, for example, with sine and cosine here, these are the same exact formulas, except for cosine is just different from sine by having that negative sign out in front. So really, if you remember this one, it's really easy to remember cosine by just multiplying by -1. You will see the same thing here for tangent and cotangent. Same idea where it's the exact same formula, except for cotangent has a -1 in front. And again, lastly, same thing with secant and cosecant. Same exact formula. It is just that this one has a negative in front. Okay, let's go ahead and move on to some problems and see how we can apply these rules. Okay, so number 2 asks us to find the derivative of y equals inverse sine of x at x equals 1/2. So you will notice here that we do not have to use the chain rule. This is a pretty straightforward problem because we just have x here. Therefore, when I write out my formula for y prime that I have memorized, it's going to be 1 over 1 minus x squared, and that is all square rooted. And again, that's just because I don't have to use the chain rule, so I don't have to include u and u prime. Okay, so now all we have to do is plug in for x. We're going to plug in 1/2. So this would give us 1 over the square root of 1 minus 1/2 squared, which is equal to 1 over the square root of 1 minus 1/4, which is equal to 1 over the square root of 3/4, and that is equal to 1 over root 3 over root 4, which is just 2. Now we can multiply by the reciprocal on top and bottom to eliminate our denominator here, and we would get 2 over root 3. So again, this would give us y prime of 1/2, which is equal to 2 over root 3, which would be answer choice A. Okay, so question number 4 says compute the derivative of inverse tangent at x equals 1. So once again, we do not have to use chain rule here. This is really straightforward because we just have x here. So my derivative y prime would be 1 over 1 plus x squared. Really straightforward with these trig ones. And now we're just going to go ahead and plug in 1 for x. So we would get 1 over 1 plus 1 squared, which is just 1 over 2 or 1/2, which is answer choice A. Okay, so number 6 asks us to find the derivative of arcsecant of x squared for x is greater than 1. Okay, so first we have to recognize that we're going to have to use the chain rule here. So let's go ahead and let u equal x squared. And let's go ahead and take the derivative of that to get u prime, which is 2x. Now let's go ahead and plug it into our formula. So y prime is equal to u prime over the absolute value of u times the square root of u squared minus 1. So now let's go ahead and plug back in. So u prime is 2x. The absolute value of u would just be absolute value of x squared. And then again, times the square root of x squared minus 1. Now let's go ahead and just clean this up and simplify everything down. So our numerator can just stay as 2x. Now, absolute value of x squared. I'm actually just going to graph this off to the side so you can see it. The absolute value of x squared would actually just look like x squared. And that's because the range of x squared would be y is greater than or equal to 0. Now, our domain given here is x is greater than 1. So really, all we're looking at is like this section of the graph over here. So if we took the absolute value of that, it would just still be x squared. So I'm going to go ahead and just write that as x squared. And then again, times the square root of x squared, which is x to the 4th minus 1. Now, last step, we just have to go ahead and simplify here. So I'm going to cross out this x, and I'm going to cancel it out with one of those x's in the denominator. And I'm going to get 2 over x times the square root of x to the 4th minus 1 for my y prime, which would be answer choice D. Okay, so number 8 says compute the derivative of y equals inverse cosine of the square root of x. So once again, here we are going to have to use the chain rule. So let's start out by designating u equals square root of x, and then our u prime is going to be equal to 1 over 2 square root x. And now let's go ahead and write out the derivative. So y prime for inverse cosine is equal to negative u prime over the square root of 1 minus u squared. Okay, let's go ahead and plug everything in, and then we're going to have to simplify it down. So negative u prime, which would be 1 over 2 root x, all over the square root of 1 minus the square root of x squared. All right, now we're just going to have to simplify this mess a bit. So first things first, I'm going to go ahead and multiply by 1 over my denominator. So let me just kind of show that in blue. So basically, I'm just getting rid of my compound fraction. So I'm multiplying top and bottom by 1 over the square root of 1 minus the square root of x squared. So times 1 over square root of 1 minus the square root of x squared. And so that is going to give me just one fraction. This is just going to cancel out, and I'm going to be left with negative 1 over 2 root x times the square root of 1 minus the square root of x squared. So our next step, let's go ahead and just simplify this. So the square root of x squared is just x. So this would become, let me actually just move up here. So this would become negative 1 over 2 times the square root of x times the square root of 1 minus x. Okay, now there's not a whole lot we can do from here. I think the only thing we can do is we can just multiply these two square roots together. So it's going to be negative 1 over 2 times square root of x times 1 minus x. So just like that, okay? Now let's go ahead and take a look at our answer choices, and it looks like it would be answer choice A.